welcome to Scientific Frontiers, and this is your host, Daniel Reeves. Tonight, we're taking a look at a theory that's been quietly gaining attention in the scientific community. One that challenges some of our most basic assumptions about reality itself.
Oh my God.
Did
you get sleepy?
A researcher known for his work in complex
Yes, I dozed off.
analysis.
Thank you. It's good to be here.
Dr. Laurent, your earlier work, your white paper with your colleague, Cross-Dimensional Resonance, a Preliminary Theory, presented at Miskatonic University, has now evolved into what people are calling the Celestial Dimensions Theory, which at this point is already being
I'm sure we've passed this road before,
something
haven't we?
in certain scientific circles. So,
If you want, you can pull over somewhere suitable.
Attempt to describe something we think may already be part of reality,
We had an accident.
even if we don't normally perceive it.
Excuse me?
What we experience as a single continuous world may actually be one state among
We had a
separate,
car accident.
separate worlds exactly.
We're dead.
More like,
What? Honey, don't be ridiculous.
structures, existing in the same place at the same time, but not interacting in any obvious way. Under normal conditions, we're effectively confined to one of those states.
how did you arrive at this idea in the first place, that there could be separate realities existing alongside our own? Is this based on something you've actually observed, or is it still purely theoretical?
I can't move. I can't feel my body.
Theoretical, but it's not coming out of nowhere. We've been working with signal analysis for a number of years, radio frequencies, mostly looking at how complex systems behave under controlled conditions. And at some point, we started noticing patterns that didn't quite make sense, at least not in the conventional sense. We developed some custom equipment to take a closer look, just to isolate variables, make sure we weren't misreading the data. And the more we refined the measurement, the more consistent those patterns became. They weren't random. In some cases, they even appeared to respond to changes in the system. That's really where the theory started to take shape.
You're running a private energy research company. Was this theory something you were actually looking for, or did it just happen?
It wasn't the original goal. The work started very clearly as energy research, efficiency, stability, resource optimization. That's still the foundation. What changed was the behavior we started observing in certain systems.
Dr. Laurent, trying to understand the connection here. Your work focuses on energy systems, but you're also analyzing radio signals. Why use radio frequencies at all?
It's less about the radio signals themselves and more about what they allow us to measure. In energy research, especially at higher levels, you need systems that are stable, predictable, something you can track very precisely over time. Radio frequencies are useful for that. They behave in consistent ways, and small changes in the system tend to show up very clearly in the signal. So we use them as a kind of reference framework, not for communication, but for observation. If something in the system shifts, even slightly, you see it in the signal. And then in our case, we started seeing changes that didn't match what should have been happening. That's where the questions began.
Do you think one day we could actually visit those realities?
That's a question people tend to ask very quickly. In theory, if the model is accurate, there may be ways to approach those states more directly, but visit is a strong word. It implies a level of control that we don't have.
Why is it called celestial dimensions?
It wasn't meant to suggest anything astronomical or anything like that. When we first modeled these relationships, the structure didn't behave like a flat system. It was layered, but not in a simple way. More like a field, organized around points of stability, almost like reference anchors. And the early visualizations, very rough ones, looked somewhat like constellations. The alternative name was considerably less usable. So celestial state, because the structure behaves more like a sky than a grid, and it suggests distance.
Dr. Laurent, one last question. Do you see this work eventually evolving into something like a Celestial Dimensions project?
I'm not going to comment on that.